So in this session, we are going to talk about the volume and configuration management. And then we will do a couple of examples here by using some concepts in Kubernetes world. If you hear me, please type in something on the chat so I can start. Yeah, okay, let's start then. So if you ever used any kind of containerization technology before, and then if you apply these principles into some kind of container orchestration environment, most probably you know what is volume is already. So simply the volume is as you may already know, the Docker containers are stateless. That means that keeps any kind of data within the container. So whenever you stop the container, kill it, all the data within the container will be gone, right? So in order to make this data persistent, you can do several ways. You can do a couple of things in order to make this data persistent. Kubernetes has some kind of a background about volumes, and we will see a couple of strategies for that. When you go to the volume types on the Kubernetes documents, you will see lots of volume types there. For example, AWS Elastic Block Store, config map, mtdir, host path, persistent volume claim. Those are some of the strategies that Kubernetes serve us. Here, for example, what does this AWS block store mean here? Let's say that you have a Kubernetes environment within AWS cloud platform. So you wanted to store or keep some data within these volumes by isolating your containers. That can be any kind of containers that are using same volume. So you can do this like this. In AWS, you already know the Elastic Block Store. This is some kind of hard disk that you can put your data in. Before, you needed to create Elastic Block Store, and you needed to provide your block store ID to the Kubernetes environment in order to attach that volume to your Kubernetes environment. But we will use a couple of different examples to make this automated. So that means we don't need to create a block store and then provide that ID to Kubernetes. Instead of that, the Kubernetes environment will do this automatically by using some cloud plugins within there. In this session, we will use Google Cloud Platform, but the main logic is the same, no difference. So our first volume type is mtdir. Mtdir is something like firstly created when a pod is assigned to a node. And when you use mtdir, it is initially empty. So this folder will be populated after your application run. When you remove your pod, this folder will be deleted forever. Okay, so you need to keep in mind this while using mtdir volume type. When your pod crashes, this is a very normal situation. It will not be deleted anyway. It can be still accessible across the containers. So here, let me provide you an example for this here. In this example, it will be very simple. So, by the way, let me create a separate namespace here before start. So I will create a namespace which is called webinar, for example. This exists. Let me create another one. Volume webinar. Okay, I created a separate namespace here, and then I will provide an alias for this. For example, k is equal to kubectl and volume webinar. So whenever I say k get poll, for example, I will get this kubectl actually executed against this namespace. So simply, I will create a YAML file, empty example YAML, and then let me open this folder within item editor. So I will put this one. I think this is better. So within this file, we will do this. Okay, so here I am saying that this will be a pod. So I will run a pod, and within this pod there will be a container. Actually, there will be two containers here, and first one will write some data into a file which is called etc timelog.txt, and then this container's name is busybox1, and then I am mounting a volume here onto this host path, mount path, and then my volume name is my volume. So when if you want to understand what is going on with the volumes, you need to first look at here, the volumes section. There is a volume here. This is a list, by the way. And then this volume name has a type empty there. Here. You can provide lots of properties here, but this will be out of scope of this session. By the way, I think there is an echo here. Let me see. Yeah. So I am muting also. If you have anything to ask, you can unmute yourself and then ask. No problem there. So I will make a correction here. So okay. So let's get back to our volume configuration here. As I said, we have two containers, and both of the containers are using same volume. That means they can share their data by using this volume. We have only one volume. That this is the option. This is the name that you already provided. Let's say that it is my volume, and the type of the volume is empty there. I am mounting this volume into both of the containers here. So you need to provide what is the name of the volume you will use. So as you can see here, both of has name my volume, okay? And both of the containers mounts that volume into their container by using this path. So when you write a file here, etc timelog.txt, you actually write this into the volume also because it has the same path here. In the second container, you will see that it tries to tail that file, okay? So the first container will write to this file, and the second container will try to tail that data from this file. So we will be ensured that, okay, this volume is running correctly. So our configuration is okay. Let's apply this configuration first. Okay. Okay. Do this and yes. Here we have empty-dir example, the YAML, and I will apply this one. Okay, the empty-dir pod is running. As you can see, there are two containers inside the pod. So let us do some logging here. I just wanted to see the logs of empty-dir, and then I want to provide. By the way, I will share my screen into two pieces. First one is busybox1, and the second one is busybox2. So as you can see here, the first container writes data to that file that is already mounted with a volume. And then, as you can see in the second container, it is able to tail that file for the data is written by this container, the first container, okay? This is the basic scenario of using empty-dir. Let me switch to the host path. So if you have any question for the empty-dir volume type, you can ask. So let's go to the host path. In this volume type, files and directories are not created from scratch. Almost nearly, it can be scratch, but there are another scenarios. The shared volume between container and host has some strategies. For example, directory or create, directory, file or create, file, socket. So here, let's say that you are trying to mount a volume into your container, but there is no directory or file actually in the system. So you can use directory or create in order to create a directory during the mount if the directory not exist on the system. You can also use the file or create for the file mounting. But if you use directory or file itself, and if the directory or file does not exist on the system, you will get an error because you are saying that, okay, this directory already exists, so please do not create that. Let me provide an example for this. This will be a simple example. We will go back to our folder and say that host path directory. Within this file, this time I will use here, as you can see, there are only one container here, and then I'm trying to list all the files under this test/test folder. And what is this /test? Actually, this is a host path volume type, and my volume name is my volume again. And then the type of this host path is directory. So I am sure that this TMP folder already exists within the Kubernetes cluster. So it will mount the TMP folder directory that exists on the Kubernetes node into the containers here. So when I do al, I will see the content of TMP that already exists in the container, Kubernetes node, sorry. So let me do this. Okay, the host directory is created. Let me check the pod if running or not. Okay, we have this pod, and then okay. As you can see, once the container starts, it tries to list all the files under this test folder, right? Actually, once the container starts, there is nothing here, slash test, because I have written nothing here. But since I am using volume, the TMP folder is mounted to this test folder. So actually, you are seeing the content from the Kubernetes node, okay? It's very simple. Let me create an example for directory or create in order to see different kind of scenario here. This time, I will say that host path directory non-existent. This time, there will be no directory on the system. As you can see here, again, I am trying to list all the files under this folder, and then this time I am trying to mount this folder into this, okay? So if there is no folder, and yes, this folder does not exist on the system, so there will be a creation, and after that it will be mounted to the entire container. Let me apply this one also. Directory, non-existent. Okay, let me delete those ones because we will get some memory errors. So I will delete this and this. Let's say that this section is for this section our real-time dashboard, okay, for the pods. And then we will see this container started. Mm-hmm. So our pod is still in the container creating phase. So let us wait for that to be finished. I hope it will be start soon. Not created yet. So we can do a describe here. Okay. Describe poll in order to refresh our background information, right? Like we used in previous webinars. Yeah, describe. I think, let me change the name of this. To another one. So I will force delete this one. Okay. So, okay, I force deleted it. And then I will apply another one, non-existent. That directory already exists on the system. So when we use that directory create, it will try to override that folder. So, but this is read-only system. We need to wait for that for the new system here. It is not able to. Okay, then I will do this one. And then okay, it's running. I forgot to change the path because I was trying to write the strongly protected path, so I changed it. And then when I say klogs f, and then this one, so there is nothing there because it is newly created, and then it is very normal to see nothing within that folder. Okay, this was the second volume type, and we have seen different type of host path. Let's switch to another one. So persistent volumes, what are they? Until now, we see some kind of volatile volume types. Whenever you delete your pods, it will be automatically deleted. But here, let's say that you have a huge system, and then you want to make your containers use same volume at the same time. That can be a database, for example, or that can be, for example, if you are using Apache Kafka cluster, it is very normal to use same volume in order to store some data into that volume. Okay. So here, for example, 1 year before, we needed to create a EBS store first on AWS and then provide that ID, as I said earlier. But now, in order to create a persistent volume here, the Kubernetes will help us to initiate this process by using its plugins automatically. Okay. In persistent volumes, AWS Elastic Block Store is an example for this. But how can we automate this process? I mean, whenever you try to mount a persistent volume into your pod, how can you do this operation? You can do this by using storage classes. A storage class is a way of describing available storage types. This can be defined according to platform you're using, like AWS, Google Cloud Platform, etc. Let me provide you an example for this. So here, I will create another file, which is called yeah. And then I'm trying to create a storage class here. As you can see, I'm saying that, okay, my name is GCPSC. This is your name. You can provide anything here. And then I am providing my provisioner. Here, as you can see, there is a provisioner called GCEPD here. And then I am providing my type. So since I am using Google Cloud Platform, I am able to list all the disk types by using single command. So here, as you can see, there are lots of disk types here according to regions. So PD SSD is one of them, PD standard, local SSD, etc. I am saying that I will use PD SSD. When I say that, I needed to apply this first. Let me apply this one. And you can list your storage classes by using SC. And yeah, GCP SC, as you can see, it is there. Okay, so I have storage class right now. So what else? What we can do after this point? We need to create persistent volume claim here. So you have a system, okay, it is ready. There is a storage class and it is ready. So you can claim your volume by using persistent volume claim by using this notation, okay? So we provided, we already created our storage class. So within the persistent volume claim, we will provide our storage class, which we already created. We can provide access mode, and then you can provide amount of storage. So there is a huge system there. You can claim any kind of data, any kind of amount from that storage class. For the persistent volume claim, I will create another file. Here. And then within this persistent volume claim, I simply provide my definition again. It is very simple. As you can see, this is a kind of persistent volume claim, and I'm using version 1. Provide your name and simply provide your class name here, GCP SC. So this storage class name is a simple isolation layer, okay? You can use this name on every place within your Kubernetes cluster. I am saying that this will be read-write once, so that means I will be able to read, write from this volume, mounted volume, and then I will do this per container. I will be able to access this volume by only one container. So I am saying that, okay, I will need 10 gigabytes of this disk for my system. Let me apply this one. So when I say this one, k get PVC, you will see your claims here. Describe. Sorry. You can see details by using this one. So this is successfully provisioned, and we will be able to use this for one of our containers, okay? And then it is time to create a container, create a pod in order to use this persistent volume, okay? So I will say that this will be a pod with, sorry for that. So this is another pod definition, but this time I will not use mtdir or host path. This time I will use persistent volume claim in order to get dynamic volume for my pod, okay? So here I am trying to write date information to this file again, but this time I am trying to use volumes here, and this time it will be persistent volume claim, and just provide your claim name here. I already created GCP SC claim, so there will be no problem with this. And then the mount operation will be occurred within that folder. Let me check if there is any other pods. Okay, I will delete this one. Okay, and then apply dash pod with this one. So container is creating. Okay, running, cool. And logs. There will be no logs here, but let me describe this pod in order to see what's going on there. As you can see here, we successfully used this persistent volume claim and then started out our container. As you can see, on previous state, where is it? Here, okay. As you can see here, this claim was in pending state, okay. Once we created our new pod here, you see it is bounded to this pod, okay, with its name. And now, right now, this pod has a capacity that we'll be able to write this kind of amount here, and then there will be no problem. So this pod is already tries to write some data on some path, okay. I will try to create another pod here in order to check if this pod will be able to read that data by using that volume. So I will create another pod here, new file. This time it will be pod with PV, and this one is for only read. So I have another pod, and I have another pod definition here. Okay. As you can see here, this time this pod will be try to tail this test PV time log txt. So within the volume mounts, I am using this one, and then my volume type is this persistent volume claim, and same with this one. Let me apply pod with here. Okay, our second container is on the way. Container creating. If you have any kind of question, just interrupt me and ask your question. No problem for my side. So I will do this one, get pod. Let me delete those two first, and then as you can see, I deleted my pod, but the system is there, PVC. So I will do this, delete PVC, and then I will do a fresh start. So apply GCP PVC. So it is in pending state again. Pod with PV. Okay. I'm trying to, okay. So I have two pods are already running here. First one is trying to write into our system. And let me see the logs of the second one. As you can see here, it is able to tail all the information because they are both using same volume, and then they are already able to read same data since they are using same volume. So what else? What else we have for the volumes? I will delete both of the containers again, both of the pods again. Okay, here. And then let me check if they are running or not. Okay, they are terminating. I will do this. I will recreate the second pod, and I see that, okay, the data is there, and we are able to see the same data. I think we deleted all the pods. So I will apply the read one only. Okay, it is running, as you can see. And then when I check the logs for this one, as you can see, the data is there and no problem on that side. So, when you say read-write runs can be mounted by node as read-write only once, and only one pod can use this. That means you can use this read-write once only for one node. Read-only many, there are too many types for this, and then they can be mounted by many nodes, and they can be read-only or read-write. There cannot be a situation like this, read-write many. Sorry, what is that? Read-write, read only once. There is no such a case. There are only three. Let's switch to the config map. So if you are trying to deploy an application to the Kubernetes cluster, most of the time you will need to use configurations, right? You can do this in several ways. One of them is the config map. I will delete. Okay, let me delete those. In order to create a config map, you need to provide some key value pairs as a basic example. So I will create a folder within this folder. That means there will be another folder here, config map, and then there will be a file within this application properties. Let's say that there is a property here. It is port is 8080, and then name is product. Let's say that I have this type of properties here. In order to create a config map by using some existing configuration file, I can do this one. I will create a config map. Just provide your config name here, and then just tell from which location you are trying to get your properties, okay? So there is a config here. Let me describe this. When you do this, you will see that there is a data in this config map, application properties. By the way, you can use any as much as you can. If you have any kind of other property file, you can use all of them. And since I have used only one, I am seeing that there is only one property, application properties here, and then there is some key value pairs within this config map. So then I will create another pod definition here, new file, pod with config map. Here, this time, I will use this notation. It is very simple. Again, I am creating a pod, and this time I will try to print the content of these application properties under this folder. So basically, when I start this container, there is no such a folder, right? And then, yes, there is no such a file. Okay, so how can we populate this data by using volumes? Okay, there is volume mounts here. It is same structure. I am using test config map folder. As you can see here, it is same folder. And then I'm using my volume as stated here. This time, the type of the volume is config map. Config map is for config map is for mounting the key value pairs into your containers. Okay. So config map name is application config. Okay. I think you got the point, because you need to create config map first and then mount this config map into your pod, into your containers. Let me create this pod. Okay, running. I will do different things this time. Let me see the logs first. Okay. As you remember, once you start this container, it will try to print the data of application properties within this path. Okay. As you can see, port is this one, name is this one. It is very simple. And then you can also do this if you want to be sure. Pod with config map. I'm simply interactively going into the container. So here you can see that test config map and application properties. Okay, and when you see the exact details here, it is something like symbolic links. Okay, it goes to somewhere, data, blah blah blah, but the content is same. Okay. And the main properties here, the main point here is when you update the config map, you will see the changes within the container right in time. Okay, so I will do this. I will do some changes within the file. Let's say that within this config map, I will change this to this one. So since I have changed this file, somehow I need to refresh my config map. Okay, in order to refresh my config map, I will use this one. Normally, by the way, as you remember, we have created our config map by using this interactive version of the command. Okay, you can define a YAML file, and then you can put your definitions here within the YAML file, and then you can apply that config map YAML file. But we use this one. So since we have no YAML file to reapply again, I will use this notation. So here I am saying that, okay, create a config map that has a name application config from this file. But this time, once you create this config map, just replace with the current one. So when you do this, one, this already exists. Sorry, I cannot use this alone because there is a dry run there. So actually, this is something like this: k get config map. Okay, we have created our interactive on the terminal, but you can see the YAML definition for this config map. So I have updated the properties file, and as you can see, it is 881. And I have done nothing with the pod. I have not restarted the pod. So I assume that the value is reflected into the container. So I will exec into the container again. And then when I say cat, so I think we need to wait a while, but it should already update it. Let me see the logs of the, by the way, let me get pods. Only the first time it. Yeah, it is reflected here. So, for example, if you are using a Spring Boot application, you can refresh your configuration files, and then you can refresh your context by using this notation. So this config maps is simply used for storing your key value, already using key value properties into the Kubernetes system by using this config map. What else here? Let me check my slide. Okay, I think that's all with the volumes. If you have any kind of question, I can happily answer that. Um, yes, yes, this is used as a best practice within the production environment. And we are storing our properties by using config maps. And you can also use when you create your config maps like this, there will be no history for this, okay? But if you use another notation, I mean the YAML file, that will be very historical, so you can track the changes according to time. When will you post the comments? So is the comment for that I used in the webinar? If you mean that, you can. I will publish the video, by the way. I think there is no limit, but let's say that in a typical application configuration, it shouldn't be more than a couple of megabytes. Okay, so it depends on what you are trying to store within that property file. I assume you are not trying to store any kind of binary data within that property, but I couldn't see any kind of limitation about the size of config map. Okay, if you have no other question, see you in the next webinar. By the way, there will be next webinar on next week about the Kubernetes authorization and secret management. There will be, again, workshop-like scenarios here. Thank you all for your time, and see you in the next webinar.